All right, here's the last page of the skills test practice number 11. That's fine. Number 35, the equation of the parabola that runs through 3 points. First, we have to remember that we're going to use standard form. So ax squared plus bx plus c. Zoom out a little, that's better. What you're going to do is you're going to take these 3 points, you're going to plug them in for x and y to create 3 equations. For example, on this first coordinate point, 6 is going to go in for y, 1 is going to go in for x, 1 squared is 1, so 1 times a is just a, and then b times 1 is just b, and then all the equations are going to end with plus c. So that's the first coordinate point plugged in for all the x's and y's, and we do the same thing for the other 2 points. 34 goes in for y, 3 goes in for x, 3 squared is 9, so we write 9a rather than putting the number after the letter, and then b3 would just be 3b to have it make more sense. So that's plugging in the second coordinate point, and then the third one, 63 is equal to 16, because that's 4 squared, and then 4b, and then c. All right, at this point, you need to choose one of your equations to multiply by -1 so that it will cancel with the other c's. I like to pick the a, that's the smallest, so I'm going to multiply this entire top row by -1. And you'll see why here in a second. That would create that equation. Everybody changed to negative here, but I'm going to add this new top equation to the middle equation, and those c's are going to cancel. So 34 and then -6 is 28. 9a and -1a is 8a. And 3b with a -b would get you positive 2b. No more c's. Now I take this top equation and I add it to the bottom equation. And the c's are going to fall out again. So 57 and 15a and 3b. So now I have 2 equations with 2 unknowns. I want to combine them so that a letter falls out. I would probably choose the b's, since an 8 and a 15 are going to generate some large numbers. So I'm going to turn these 2 numbers here into 6's. One's going to be positive and one's going to be negative. So I'll multiply the top row by -3. So I see a -84, a -24a, and a -6b. Multiply the bottom row by 2, 114, 30a plus 6b. Now the b's are going to cancel when I add these equations together, so I get 30 is equal to 6a, therefore a has to equal 5. I'll put a little circle around that, even though that's not my answer, so I can find it. All right, I'm going to take that 5. I'm going to head back to one of these 2 equations to solve for the b value. I'll use this top one right here, so I'm going to put 5 right there, and 8 times 5 is 40. So 28 equals 40 plus 2b, and then solve that for b. Subtract 40, gives you -12, divide by 2. B ends up being -6. A little circle around that. And then you take that and you head back to one of your original equations to solve for the third and last letter. I would use the top equation, obviously, there. That's friendly, huh? 6 equals, A was 5, B was -6, and then C is left. And that's -1. If you move it over there, you're going to get C is equal to 7. And the reason I lightly circled those, because it does say find the equation. So right now I'm going to find a gap here and write the answer. Y equals, taking my A, B, and C and plugging them back into our standard form equation. 5x squared minus 6x and plus 7. Now, if you have a graphing calculator, I recommend taking your answer and, let's see, plugging it in into the graph. So I hit y equals, in case you're wondering where I'm at, 5x squared minus 6x, excuse me, and plus 7. Now I'm going to go to the table. So I hit second graph, which is the blue table for me. I got to scroll to the right section. So sorry, bear with me while I scroll up. And I'm going to check to make sure that these 3 original coordinate points are in my table. 1,6, check. 334, check. And 463, check. They're all there. And that way you know you got that right. It's not too long or too hard to do if you've got a nice calculator. If not, what you should do is take your values and plug them into one of the other two equations that we didn't use and see if you get the correct or true answer. Okay. 35B is the same thing. You can check the solutions if you want to see the solutions to that one, but for sake of time, I'm going to jump down here to these bottom ones. Now, typically these word problems are another 3 equations, 3 unknowns, but to speed up the process, since you've already done it here, I've given you the equation. Okay, so understanding the picture is going to be important here. This says Tiger Woods hits a golf ball from an elevated tee, and I'll use this space up here to talk about it. So he's got an elevated tee, and he's hitting a golf ball, and a golf ball obviously is an upside-down parabola, and this is the equation of that parabola. Let's put the XY axes, or the origin, right even with the fairway, but the elevated tee is up there on the y-axis. So a parabolic equation is applied to the ball. This will be important to recognize that the x is the number of seconds. Sometimes the x-axis is a distance that he hits the ball. Sometimes in this case, it's the number of seconds that the ball is actually in the air. So that's important to know what the x-axis is. The y-axis is feet. It's always good to know whether that's feet or yards, because these problems will change up and you'll have to do some converting. And now we head to the first question. How high above the fairway is the tee box? So this guy right here is the tee box. Here's the fairway. Basically, it's asking what's the y-intercept. To find the y-intercept for any equation, we let x be 0. So if I rewrite this original problem and I put 0 in for the x's, I get this expression here, which if we solve, 0 and 0 and 8 is just 8. All right, so 8 feet would be the answer to that guy. When does the ball hit the fairway? So we're looking for this guy right here. What's this x? Remember, x is time, so this would be seconds, and you're looking for when. So when does the ball hit the fairway? Means find the x-intercept, and the x-intercept is found by letting y be 0. So I go to my original problem that's given to you. I let y be 0. And you get this ugly equation, this little quadratic here that's equal to 0. That's not going to factor. I can even tell you now it's not. So we have to head to the quadratic formula. And we get negative b, so negative 50 plus or minus the square root of b squared, which is friendly, I'll write that, 2,500, minus 4ac, 4 times negative 12 times 8, which we'll do here in a second on our calculator, all over 2a, so negative 24. Now, quadratic formula is going to generate 2 answers. One of those answers is right there. We don't want that one, though. That's going back in time, since the x-axis is time. We're not going to go back in time. We're just going to go forward in time. So of the 2 answers here, we're going to disregard this one here, which you can see is going to be a negative x value. We only want the positive one. And typically, since we're dividing by a negative here, I tell people, hey, use the minus first, because we want this to be negative up here, because a negative divided by a negative is back to positive. So I tend to recommend using the minus 1 first. So let's head to my calculator here. Negative 50 minus the square root of 50 squared, which we already know is 2,500, minus parentheses 4 times negative 12 times 8. Let's close those parentheses. I like to hit equals after the numerator. There's that negative answer I knew I was going to get. And we divide it by the numerator, or the denominator, sorry, negative 24. And I got 4.32. So 4.32 seconds is when that ball hits the ground right there. And I know it's not this one there. That's going back in time. Okay. Find the 2 times the ball is at a height of 52 feet. Now, we already know this is 8 feet. 52 is somewhere here. So it hits 52 there and hits 52 on the way down. That's why the question says 2 times. So if we were taking a Google form test, I might just ask you for maybe the first time it hits 52 feet or the second time. So be aware that there's two different answers, and that's just because the quadratic formula is going to give us two answers, and you have to know which one's which. So this means 52 feet is your y value, so we know 52 is the y. We're trying to solve for x, so it's very similar to the previous problem. I'm going to put 52 in there for y and solve this thing with the quadratic formula. But I've got to bring this 52 over. See, this guy was already equal to 0. Equal to 0 is what we want before we use the quadratic formula. So we have one extra step to do, and that's to subtract 52 from both sides. As soon as you do that, you got the same looking equation where you head to the quadratic formula. So negative 50 plus or minus square root of 2500 minus 4 times a times, and this is the difference here, right? Negative 44 all over 2a. So the only thing that changed was that c value in our formula. And since it wants the 2 times, we're going to find both answers. So take a little bit of typing. We'll write down both. So negative 50 plus the square root 2500 minus 4 times negative 12 times negative 44. I like to hit equals and divide by negative 24. 1.26. That's our first answer. 1.26. That's that first guy in the diagram. 1.26 there. And now start all over again. Type everything all over again, but change that plus to a minus. So I like to use the previous entry. Previous entry will retype something that you've typed previously. I'm going to scroll back now and change that plus to a minus. Okay, so we're doing the numerator of our quadratic formula. Now we're doing the minus part. I'll go ahead and hit equals. Then I'll hit divided by negative 24. And I get 2.90. 2.90 seconds. There's the 2 times that this ball is 52 feet above the ground. Okay, the other answer to the bottom one is on Canvas there if you want to go check your solutions, but I'll stop right there, and good luck.